Hi everyone! Today we're going to start our unit on quadrilaterals. We're going to begin this unit on quadrilaterals by discussing polygons. Polygons, as you already know, are closed plane figures with the properties where they're formed by three or more segments that are called sides. Each side intersects with the other two sides, each at one endpoint. Polygons can be broken into convex and concave. Convex polygons are polygons where no line containing the side of a polygon contains a point inside the polygon. And concave shapes are polygons that are not convex. Basically, convex polygons are the ones where all the sides pop out. Concave have areas that jut in. Below is a list of all the different types of polygons. You've seen these names before, understanding that the names relate to the number of sides. Just like with triangles, equilateral polygons have all the sides congruent. Equal angular polygons have all their angles congruent. Regular polygons are polygons that are both equiangular and equilateral. Examples of convex and concave polygons can be seen down here in example 1. A convex heptagon, heptagon having 7 sides, could look something like this. Notice that all the endpoints are outside the figure. A concave heptagon has an area that moves in, so these points here are inside the polygon. Now looking at angle measures in polygons. First, we need to review the term diagonal. A diagonal is a segment that joins two non-consecutive vertices of a polygon. Notice that when we talk about rectangles, we know that it goes from one corner to the other. But in something like this hexagon here, a diagonal can go from 2 to 6, 2 to 5, or 2 to 4, because the definition says that it just has to be two non-consecutive vertices of a polygon, consecutive being next to each other. The next thing that's noted here is that the sum of the measure of the interior angles of a convex n-gon is n minus 2 times 180. This is an important formula you need to memorize. Based on this formula, we also know that the interior angles of a quadrilateral are add up to 360 degrees. Also, important information for you to remember. Now, using this information, let's look at some examples. Example number 1. Find the sum of the measures of the interior angles of a convex octagon. Well, thinking about an octagon, we know that n is going to equal 8, because an octagon has 8 sides. Using the formula that we stated up here, n minus 2 times 180, we can see that if I plug 8 in for n, I find out that the sum of the interior angles of an octagon total 1080. The sum of the measures of an interior angles, example 2, the sum of the measures of the interior angles of the convex polygon is 900 degrees. Classify the polygon by the number of sides. Using that same formula we used above, we can work backwards. So since we don't know how many sides the polygon has, we know that n minus 2 times 180 equals 900. We can then divide both sides by 180. N minus 2 then equals 5. And once we've done that, we now have a simple equation to solve, and we can see that this n equals 7. And if n equals 7, we know that this is a heptagon. Using what we just did, you can go ahead and try examples 3 and 4 on your own. When you're done, come on back and we'll continue with some more examples. Example number 5 says to use the diagram to find angle S and angle T. The first thing I need to look at is what type of figure is this shape. This polygon has 1, 2, 3, 4, 5 sides, so n equals 5. Now, what should the interior angles of this figure equal? Using n equals 5, I can use the formula I used on the previous page to find out that the interior angles of this pentagon should equal 540 degrees. Well, I know 3 of the angles, total 334 degrees by adding the 3 angles I have. If the interior angles have to equal 540, and I already have 334 used up, I have 206 left for these 2 angles. Looking at angle T and angle S, I notice that there is a mark on them. This green arc indicates that they are congruent to each other. So if together they're 206 degrees and they're congruent to each other, I can divide it in half, and each of those angles equals 103 degrees. Example 6 states that the measures of the 3 interior angles of a quadrilateral are 89, 110, and 46. We need to find the 4th angle. If you remember on the previous page, we stated that the interior angles of a quadrilateral equal 360 degrees. We need to remember that. If we didn't remember it, we could use the formula we used in the last step using an n of 4. But now that we do know that, and we're going to memorize that, I see that I have 3 angles in this quadrilateral already that total 245, and since the angles in a quadrilateral add up to 360, I can do the simple subtraction to find the 4th interior angle at 115 degrees. The final theorem that we have today is the sum of the measure of the exterior angles of a convex polygon. This is always 360 degrees. It doesn't matter how many sides a polygon has, the exterior angles always add up to 360 degrees. So looking at this diagram, if you notice, this shape inside, while not a regular shape, is a quadrilateral. It has 4 sides. Therefore, it has 4 exterior angles, you can see, which are created by extending each of the lines. And I know that those 4 angles have to add up to 360 degrees. So I can set up a simple equation. X plus 2x plus 89 plus 67 has to equal 360 degrees. And when I simply solve that, I will see that x has to equal 68. In example 8, a convex hexagon has exterior angles as listed. The exterior angle at the 6th vertex is whatever we need to get to, again, 360. So let's begin by seeing what we have. The sum of the angles listed in the problem is 283 degrees. Since the exterior angles of any polygon equal 360 degrees, I can simply do the subtraction to see that the 6th vertex is 77 degrees. Example number 9 pulls everything we've done together. It says find the measure of an interior angle and an exterior angle of a regular pentagon. If you remember from the very beginning, regular means that all the sides and all the angles are of equal length. So if I know the sum of the interior angles or the sum of the exterior angles, a simple division by the number of sides will tell me the measure of an individual angle. So we're working with a pentagon. So a pentagon has 5 sides. Knowing that a pentagon has 5 sides, I can determine the sum of the interior angles using our n minus 2 times 180. So 5 minus 2 is 3 times 180 gives me 540 degrees on the interior of the pentagon. If I take that 540 degrees and divide it equally by the 5 angles of the pentagon, I will see that each interior angle equals 108 degrees. The exterior angles of a pentagon add up, as they do in all polygons, to 360 degrees. So if I take the 360 degrees of an exterior angle, of the exterior angles, and divide it by the 5 exterior angles in a pentagon, I will see that each exterior angle equals 72 degrees. Now notice here, if I add up 108 and 72, what would I get? I'd get 180 degrees. If you look back at the diagram at the top above on this page, you will see and remember from triangles as well that an exterior angle and the interior angle next to it are supplementary. So your interior angle and your exterior angle should always add up to 180 because they're a linear pair. It's a great way to check your work when you're doing these problems. Number 10 is a little tricky. It says that each interior angle of a regular n-gon has a measure of 168 degrees. Find the value of n. Well, if I don't know how many sides the figure has, I don't know what the interior angles add up to. But I do know that the exterior angles always add up to 360. So, if I know that the interior angle of a triangle is 168, can I find the exterior angle? Sure, we just talked about the fact that the interior angle and the exterior angle form a linear pair. So that linear pair, if 168 plus another angle have to form a linear pair, I can simply subtract from 180 to see that the exterior angle at this angle must be 12 degrees. Since it's a regular n-gon, all of the exterior angles have to be the same length, or same measure. They are all 12 degrees. Well, if each angle is 12 degrees, and there are n of them, and the total must be 360, then I have to do 12 times what gives me 360? Or 12 times that magic n gives me 360. Solving that simple equation, I can see that the value of n equals 30. I know this was a lot of information. In class, we'll review these formulas and we'll practice some more with the information. Please make sure that all your notes are completed and you've tried the practice problems that I've left blank in the notes.